Okay, here's another wood gas stove. It's actually the same one I've been shooting. I think I shot a couple videos on it. And this stove is a little different than the ones I've been using. I've had to modify it a little bit to get it to work with what I'm trying to do right now. Basically, I cut the bottom out and I added this belt, which is semi-wet from water. I put some water on just to soak it up a little bit. And these are holes that are in here. And those holes were normally used in my other stove, but since I'm doing something different, I want those holes to be gone, so I don't want to use those. And I of course added this to put a little pressure on it. Same chamber, same hole arrangement on the chamber. Everything else is pretty much identical to what I've been using. This is like an interim step between the stove that I'm designing on SolidWorks, which I've learned how to use SolidWorks a lot better, come up with some ideas and how I want to design my new stove, which is going to be a 1 US quart paint can that you can buy at the Home Depot or any store that would sell that kind of item. It's an empty paint can, never been used, and it's for like mixing paint and storing different colors, I guess. But yeah, so this is just a normal arrangement. The difference, and of course here I'm using my windscreen / pot stand. With it, the difference is I've added this fan, which I've run 4 times last night successfully, but I didn't record it. So let's start with the power end. Right now I'm just running it on AC. The output is 12 volts because it's a 12 volt fan. Come on, there we go. This puts out about 850 milliamps, which is enough to run this fan on high. I don't know exactly what the fan's drawing, but 12 volts is what the fan in voltage uses, and 850 is just under an amp. So okay, the difference is with the other arrangements that I actually came up with, which I didn't shoot because they weren't successful, was that the embers would drop down and land on the top of because of the way that this has to work. The top of this fan this is the top of the fan, and it sucks air from the bottom and it comes up to the top. Right here is pretty much just the paper. The power leads come in. There's 4 leads. This is out of a computer, and so it has 4 leads. These other 2 leads we don't use. Basically I'm using the yellow lead and the black lead, which is positive and negative. And then these, I believe, go to the motherboard. Well, they all go to the motherboard, but this in actuality is just the RPM, so that the computer knows, can send the information to the chipset so that it knows what RPM the fan is running at, so it can give that information back to the chip, and then software can read it and you can kind of know what your fans are up to. So we only need to use these 2. Right now they're just roughly tied together. I just twisted the wires. I've got a 3-inch bolt, and I originally was planning to just go ahead and add this to my new stove, but I wanted to make sure that the ideas that I came up with and what I've plotted through SolidWorks and what I was designing is this piece right here. This piece is a coupler. It's basically the fan that I butchered. You know, this died and I took out the inner part. I cut it out and I pretty much made this chamber. Okay, this chamber allows me to lower the fan, still have room for air to come in. I've got a guard here to protect you if you don't want to, get your fingers in the fan. I have the air come in, go through here, and then let's just say that this is your fan, this is your stove, and it allows it to leave room in here to isolate this from the heat. So this is like I think like a phenolic resin or whatever, it doesn't even really get warm in this arrangement, and I'll show you the reason why. So with this arrangement, I just added this as a way to isolate even more of the heat from the fan. That was my main concern. So these are just stacked on each other, and then of course I've got these bolts. This is all like a temporary deal, and I'm using this stove, so I don't want to start cutting holes and doing things to my other can, the quart paint can, until I'm 100% certain that the arrangement that I come up with works. And so now the next part of this is this little deal right here. This is carbon felt. It's actually not really the true carbon felt, but what it is something that you can get at the Home Depot for when you sweat pipe fittings together in new construction, or if you're just in an older retrofitting something and you don't want to get the 2x4s. A possibility, depending on how close it is to the 2x4s, so you don't get the 2x4s and catch them on fire. You can pretty much hold this, your finger on one side, and then put a match or a lighter, and you won't even feel it. So I've sat there for like 5 minutes, and to the point where the lighter is unholdable. So yeah, it does. These are some places where something had fell through, because I don't really have any protection for any, in the whole size of those holes. Some embers will come through, but you know, like I said, I've tested this. This will be the 4th run. I'm gonna modify it. I'm going to lose a little bit of this room down here by lowering this, and then give myself a little bit more bolt, and I'm going to put another one of these fans up here and sandwich this in there. Right now I'm just laying it there, and so I'll sandwich that in there, and probably it'll be below this line, and but that's going to be down the road. So I just lay that on there, and then of course this is the top of a paint can that I cut out with a safety cutter, and I put that upside down, and it gets held in with what's left of these threads that are sticking out. Okay, and of course then you can just set this on top and it holds it, and it's a little bit high but on the arrangement, but you know, of course the top. So you can see, let me see, I'll turn it sideways. How's that? So anybody that's watching this on a computer is going to have to turn their head, but you can see it's temporarily how oh, there it goes. I didn't think I backed up enough. So you can see it's a little high, but, and then of course the pot that I'm using is in the back, but I did use it last night and it's pretty stable. So that's my arrangement. I'm going to load it up and light it on fire and boil that water, which is right now it's setting at 77 degrees. And I've got my phone there with a timer on it, and we're going to time it up and see. Well, let me cover one more thing. This is what I'm burning. It looks like rabbit pellets, but it's not. It's actually aspen chips. That's been pelleted.
Message from the dark side, Derry.
Someone's texting me. These are aspen pellets that have been chips that have been that have been. Let me grab one. Pelletized. They form these pellets, and they burn really good, but you can't burn them in a stove without anything air going through. They lock up. They form this tight arrangement, this matrix that's air just really doesn't flow through these stoves in a normal arrangement without air going up through and forcing its way through it. But I am burning these. They burn really well, and that's my fuel. Okay, let's cover one more thing while I'm thinking about it. I'm just using lighter fluid as my accelerant to start it. I've used other things in the past. For this particular arrangement, it works pretty good. Let's see what else. These are more of that pelletonized fuel, but I was thinking I could maybe use a measured amount. This is just under what I really need. About 1.5 of these to fill up this chamber. But this is a protein supplemental drink or whatever that my father's using. And so these are these containers. I thought I could put alcohol in it for my alcohol stoves or whatever. Yeah, these are the tubes that drink comes in. So, alright, let me load it up and then we'll come on back. Okay, I'm back. I have some accelerant on there soaking in. That's how much I put in of the pellets, which is, this is where I took it out of. So it's about halfway on this container. And I'm going to light it up one-handedly. Let's see how I'm going to do this. I'm going to light it up. Throw the match in there. I give it a second for the accelerant to catch, and kind of, you see some of the pellets are on. I'm going to plug it in. We'll look at the side of the container. Okay, and that quickly we are running. Like I said, the water is at 76 now. And let this catch for a little bit. I'll put this on. And the wind's not really blowing, so I'll leave it to the front so you can kind of see it as I shoot. The fan's a little on the loud side. I probably will add some type of control. Part of what's making this other stove, the new one that I'm working on, a lot more complicated. And somewhere between these fans and here, I want to be able to spin this container like this and have a plate here and a plate here with holes in it that will line up only in one position. And based on the size of the plate holes, they'll allow air to come through or stop. So I want to make a built-in air control by just rotating it like that. And I know it's going to be warm here. I'm going to have to come up with some arrangement. It runs just great on high. So it looks like it's ready. I'm going to go ahead and put this, I don't know exactly what, but I just filled this up that much water. Going to put this on. As you can see, this is roughly what it looks like. It's not practical for any real heavy use, this is just for my experimentation and just something I like to mess with, so I don't plan on using this in the field. And we will start the timer. I have a timer here. Start the timer there, and we will let it go. Put this somewhere. Now, you can already see the amount of wood gases coming out. So not only is the air being forced straight up into the container from the bottom, so it's really not a true wood gas, but it's kind of like, I think, kind of hybrid. I don't know exactly, but it's kind of burning from both ends, really. But it's pushing air up also, and more of the smoke is coming down here, it's coming up, and then being forced back in. So we're already at 94 degrees, 95 degrees, 96, it's 97 now, it just keeps rising. Yeah, now we're at 100 degrees. And of course our target temperature is 212, which is boiling. 103. As you can see, I have a probe and a hole in the back that's giving me my temperature. Let me put this down in this arrangement. Yeah, let's see if we get those both in frame. Yeah, 112 degrees. Yeah, like that. Normally, I cleaned this table off, but normally I wouldn't have all this stuff out here, but I've been doing multiple projects. As you can see, I also had dinner, so rustic style. 125 at 2 minutes. The temperature down here, you can't even tell that it's even on. Of course, the farther you get down. This is cool, of course, this is cool. As this fire burns down, it's going to get warmer down here. The part of the fire that's really truly burning on top, but it's also coming down this way. So I guess it really isn't really burning down here, but we are at 145 at 250. Got a little bit of a glare. I hope you can see that on there. 155 at 308. Here's what the fire looks like. Now let me do a quick test. I'll turn this off for a second. You can see what happens to the fire, of course. This is what it would normally look like. Okay. So you can see how much significantly more air we are ramming through here. It's kind of supercharging it. Now if I were to blow this out, I could just take a match and just put it in there, and enough wood gas residual would it would light up. It actually, I can feel the heat off of here, so it's not going to need that because it's got some embers in there. But okay, we're at 177 at basically 178 at 4 minutes. I'm going to shoot this completely live. At 7:22, it's pretty calm out. Wind's barely moving. There is some, because of how this is sitting here, a little bit of, you can't really see it there, but on the sides you can see it looking up. There's a little bit of sooting going on. We are at 199 at 445. For whatever reason, my phone will not stay still. I'll just hold it. We're at 204 at 5 minutes. 206, 207. 208, 209, 210, 211, 'Come on, you can do it. Hovering at 211. definitely boiling. We're just gonna say it was at 6 minutes at 2:11. I don't know why it didn't go off. I got the alarm on. As you can see, it is boiling. And we have plenty of fuel. I'm gonna take this through a complete burn. I would say it's at 6 minutes, so I don't know why it didn't. This thing is just hovering at 2:11. Take it out real quick. It's already dropping. So, well, the probe works, I don't know. See if we can get it to go back up. We will stop this. At 2:07 now, it's rising back up. 2:08. 2:09. $2:11. That's weird. But, you know, you saw it's boiling, so I'll take this out. We don't need that in there. Turn this off. Turn this off. And if you were trying to boil water and you wanted to purify it, you can definitely take this through if you really had to use this. Take this through to a full, any amount of time. I mean, there's plenty of fuel in there left. This part is now a little warm. I can hold it. Of course, these parts are fine. Anything that does drop through is going to get caught by this salt. It's definitely as a barrier for the heat. Now, you know, eventually it might wear out, but I'll have to cross that road when it comes to it. You can just see how much energy is contained right there. All that gas, all that wood gas is just exploding up. And if you look closer, you can actually see at the tips it's blue. I've never seen that with a regular wood gas burning. So that's the hotter part of the flame, I believe. I mean, I'm right here. I don't want to get any closer. It's definitely too warm here. I'll melt my lens, so let me just take this off with my pot grabber here. And wow, that's warm. I wonder if I can take this off. Usually with this arrangement, what happens is that the heat expands with such a tight fit, and so it's impossible. Now this is a lot warmer. I probably will take it off and just see what has happened. You can see the distortion that's going on in that grill. It's a computer fan grill. It had chrome on it, and it's all peeling off and outside the container, and this is really getting warm. Still cold down here. I would assume that if it's slightly warm here, this is stopping it. This is going to be warm up close because, you know, it gets a little hot. But this is completely cool. The then I will show you what is left of half of this container, which is what I used, the wood pellets. You could dump them both out with the ash and that. You can see how that, if you can see in there, look right around here, you can see the tip of the flame is blue right there. And then of course it comes out to yellow. So, it's pretty amazing. I have no way of measuring. Okay, so now it's starting to pretty much just be glowing embers down there. And we're producing less and less wood gas. So, we're at about 15 minutes, 14 and a half, okay, about 15 minutes on this video right now on my timer. And I think the first 3 or 4 minutes was me talking about the stove, so roughly 10-11 minutes into it. You can see the belt is just super hot. I'm going to actually take it off right now. It's really all we have is embers down there. It's not really producing anything. Okay. I'm going to take that off. I will show you. This right here is what's left. I can hold it. It's not hot at all. You can see that it's just kind of won't sit there. This ring is warm, but it's not. I can handle it. This ring is what was holding this down and giving me a place to put the stove. Okay, so we'll put those over there. Turn this off. Loud, but functioning. These are the smaller of the fans that I actually have. I actually have a bigger fan. I have a case fan. This is a power supply fan. Inside the actual power supply, what you would see from the back of a computer. Power supply fan, case fan, and CPU fan, all various sizes. Okay, let's see. Let me spin this around. I just had some vice grips so I can handle this. You can see this belt was starting to get real hot right there. Okay, now this, other than just the can itself is fine. This is really with the weight that's allowing it to sag. Put that there. Let me move this fan assembly. You will go right there. Okay. Let me make it so I can. Okay. Now these are still going to be glowing. They actually still in some areas could actually be used. I mean, you could actually use it. I didn't want to. There was no need. It wasn't producing any wood gas for me, so this is what's left. Now, of course, they'll still be burning. Okay, it's empty. Let me push those out. Okay. That is what's left. Now, if I had left it on maybe another 4 minutes, 3 or 4 minutes, those would be just pure ash. Let me get something to lay them out a little bit more. You can see on the outside there's more ash than on the inside. It's still a little hard. So there's a little bit more that you could use. And let's see here, let me lay these out. This is roughly half. I'm not going to say it's half. This is, well, here, let me just put it in the stove. and you can see visually there's still really good residual heat right there. I mean, it's really warm. Okay, so let me show you this. This is what is left in the container, and it's about right here. Let me see, right about there. It's a little less than half, but you can see where it went. Okay, so that's what's left. That's what we started with. Okay, now if you're taking this down, if I had leave this out here, you can see they're still glowing. If I leave this out here, they'll be pure ash. So that was what we left. So that's aspen chips that were pelletonized, made into pellets, and it's all, I guess, a soft wood. They burn really hot, but they burn fast. I guess if you have like a harder wood, might last a little longer. They have all varying lengths. This is really what it looks like. And just some lighter fluid on them, light them up. They don't take anything to light. Let me show you what I was using last night also. Right here. This is mesquite. These are different lengths, chips. Some of them are really small. It gets really small. That's another one. All different lengths. So those usually are a lot harder to start, but they run really good in here once they get started. So there you have it. Boil that much water. It's over 2 cups. I don't know exactly what that holds anymore. I forgot. In about 6 minutes. Probably can, depending on the weather and the wind, and that will change, I'm sure, a little bit. As you can see, now I can handle this. So, pop this chamber out. That's the size of my chamber. That's a condensed milk container. And if you're looking for a fan to use, this is what I'm using. It's going to be kind of hard. Model AD012UX-A7BGL, made by ADDA. 12 volts, 0.33 amps. Just a standard computer fan. I'm sure you can get any number of them. And next time I probably film this, I will have made this modification where I'm going to put another grate here or something way to make this more. Basically, this will be a permanent entity. All this, instead of being able to take it off, it'll be bolted on. Holding this in place will be that, and then there'll be a grate in the middle. It's end like this. That'll be done, and then I'll apply all this to my new one that I'm working on. So that's that. I'll catch you on the next one.